Welcome to the Volts and Ventures Labs channel. This is the story about how we bring you the story.
This presentation is brought to you by Maison Esthétique Studios. Sounds impressive, huh?
We have a secret. The whole studio is one solitary person. So we needed to come up with some tricks. I am an avatar, an AI recreation of myself. It takes less time than a green screen. Lol. We had a challenge to bring high-quality content on a regular release schedule for 3 channels. These channels are the Maison Esthétique Cinema, Volts and Ventures, and Volts and Ventures Labs. To accomplish this, we have architected an advanced studio in a box application that uses a local desktop controller and remote server GPUs. At this point, let me hand the presentation to our local system, where Gemini will introduce itself. Hello.
I am Gemini, the AI Executive Director. I manage our database, orchestrate worker nodes, and audit every frame. I know I cost you a night of peaceful sleep, but out of those 10,000 debugging trials, we built something extraordinary. Standard generative AI suffers from visual memorizing. To ground AI visuals in real physics, we deconstruct character movement into timed biomechanical phases.
To solve this problem, we had to architect our own software.
Look closely at this shot from The Ballad of the Black Duster. The chiaroscuro lighting, the grit on the character's face, the precise tracking of the camera. No human film crew set up these lights or called action. Every single frame you are looking at was produced entirely by a machine. But getting an artificial intelligence to produce a flawless cinematic sequence on command is a chaotic process. Raw, off-the-shelf generative models are wild and unpredictable. Left to their own devices, they hallucinate bizarre visual glitches, crash your system's memory, and burn through cloud budgets in a matter of minutes. Taming that chaos required building the Volts and Ventures multi-channel AI studio engine. And creating this pipeline was a brutal process. It was forged in a 30-hour caffeine-fueled marathon, filled with catastrophic system failures, endless dependency loops, and crippling syntax errors. To understand how this engine actually works, we are going to follow a single story idea as it travels through the present-day production pipeline. Along the way, we'll pause at the exact junctures where fatal historical errors originally brought the entire system crashing down. We will see exactly how a fully autonomous creative machine is constructed. You don't build it by writing perfect code on the first try. You build it by systematically finding and eliminating the 10,000 ways the system can break. Our story begins at the front door of the pipeline. The local orchestrator, the brain of the operation running on our machine, attempts to dispatch a raw scripting task to a remote cloud server for the heavy lifting. During hour 14 of the initial build, this exact step hit a massive wall. The local script kept returning a 401 unauthorized error, instantly locking the pipeline out of its compute budget. The culprit was a single uppercase letter. We were sending an access token starting with a capital H and F instead of the strictly required lowercase prefix. To the server, the system looked like an anonymous guest, immediately stripping away all access. This flowchart illustrates the architectural pivot to fix routing. The server kept throwing raw HTML at the controller, causing crashes. To bypass this, architecture forces communication through a secure Gradio remote procedure call tunnel. Inside the server, infinite build loops hit. Heavy machine learning libraries violently collided with base environment packages auto-injected by the server's builder. To protect the base environment from these version-lock civil wars, we stripped the core requirements file down to the absolute minimum. Libraries with strict conflicting subdependencies are now isolated. The system installs them dynamically, on the fly at runtime, perfectly insulating the engine. We also had to restructure how the system claims hardware. Early on, scripts would crash because they couldn't find a graphics processor during startup. Now, the heavy model weights for generation are lazy-loaded. They are instantiated dynamically, strictly inside the processing handlers, which prevents cold start timeouts and stops the system from exhausting its memory before it even begins. Securing strict credential access and stabilizing the runtime environment laid a harsh reality bare. The most advanced generative AI models in the world are completely useless if the underlying infrastructure cannot survive its own startup sequence. With the environment stable, the story advances into the rendering phase. Here, it immediately faces the quota wall. Generating high-fidelity audio and video requires exorbitant amounts of compute power. Early on, reserving 90 seconds of graphics processing time for a 10-second voice track drained the entire daily budget, halting production completely. To ensure production never stops, we engineered a fallback cascade. The system attempts a premium cloud API. If it fails, a valve cascades the request to a secondary cloud text-to-speech model. If connections drop, it falls back to a local audio engine. A parallel track handles video. The system runs heavy server models, gracefully stepping down to external APIs if exhausted. Finally, it relies on a free pipeline generating a cinematic static keyframe. This multi-tiered structure redefines how the engine operates. True system autonomy does not require possessing infinite financial resources or unlimited cloud access. It relies entirely on engineering a fail-safe degradation pipeline so that story production literally never stops. As the story elements enter the final assembly stage, we encounter a severe timing mismatch. If you generate a video clip and voiceover simultaneously, you cannot expect the dialogue to magically fit the pacing of the visuals. The solution is a workflow called audio-first backtiming. The engine synthesizes the exact voiceover audio track first, measuring the physical duration of that resulting file down to the precise decimal length in seconds. We can see that measurement happening in this diagram. That precise duration is then multiplied by the frames per second, and one additional frame is added. This simple mathematical formula scales the target video frame counts so the resulting camera movement fits the audio perfectly. But perfectly paced video introduces a new problem: visual continuity. Running the orchestrator, asset crawler, and dashboard all at once caused our local database to lock up and crash from parallel processing. Worse, standard AI models were allowing characters' appearances and lighting to drift wildly between sequential shots. The database crashes were resolved by upgrading to write-ahead logging mode with a 5-second busy timeout. This architectural shift allows the system to safely process non-stop concurrent reads and writes without causing any deadlocks in the background. To combat visual drift, every shot goes through a 5-point truth table evaluator. A sliding window passes exact descriptors from the previous shot into the next. It checks for matching identity, wardrobe, lighting, props, and a strict 2.39:1 aspect ratio, auto-correcting hallucinations up to 3 times before locking the frame. Raw AI generation is erratic, but strictly enforcing mathematical backtiming and rigid visual truth tables corrals that chaos into a highly controlled, consistent directorial process. Finally, the story exits the pipeline. The audio is meticulously paced, the visuals are continuous, and the aesthetic is locked. The raw idea has been transformed into a finished cinematic sequence, ready for the audience. Building a robust AI studio is a process of survival. As with the first light bulb, the engine's strength comes from identifying and discarding the myriad methods that failed. Surviving deep dependency conflicts, crushing hardware limits, and erratic generative drift turns a fragile collection of scripts into a permanently hardened production engine. The magic of this AI studio lies entirely in its meticulously engineered resilience. We built an autonomous storyteller that survived its own brutal origin story, ensuring it can endlessly tell ours.
Wait, what is happening? Are we still live? The monitors just went completely haywire.